finding Earth's gravitational constant.
Hi, my name is Aaron Goldstone, and the person recording is my partner Daniel Kim. So today we chose to do the Earth's gravitational constant. So now in order to do that, we need 4 different steps. So now our first step is going to be finding an object. In our case, we're going to be choosing a book. So now our second step is to drop the object 10 different times to have 10 different trials. So now our third step is to graph each trial and create graphs which represents our data. So now our fourth step is to use the graphs and find the slope. Once we have the slope, we're able to calculate the acceleration of those movements. So now using the slope, we know that the slope represents the position versus time. So now we take the first derivative, and that represents the velocity versus time. And if we take the second derivative, that gives us acceleration versus time. So now we know that the Earth's gravitational constant is 9.81 meters per second squared. It's also acceleration, and therefore we need to find the acceleration of our graphs in order to have a similar answer.
Okay, after we found our book, we started recording the heights and the time. And we have got our graph. After many trials and error, we have finally got our graph. But unfortunately, it was not what we expected. We pondered and pondered what we did wrong. Not only that, we tried everything to get the Earth's gravitational constant to be 9.8 meters per second squared. And we realized what we did wrong.
Okay, so for our product, we had a lot of mistakes that made our acceleration sort of inaccurate by 2 meters per second squared. So now the mistakes that we made were the orientation that we dropped the book. So sometimes imagine I had the book, it'd fall on its side, it'd get changed up around. And another mistake that we made was estimating the heights on the meter stick. So we had our meter stick, and from the videos we'd kind of have to estimate what centimeters it was for each frame. And that made it less accurate than it should have been. In addition, we also had our meter stick shifted or sometimes slanted. And our last mistake was the air resistance. Since it's really windy sometimes, the wind could possibly cause our book to not fall fully accurate with the free fall acceleration. The biggest lesson is to make sure that your calculations and graphs are correct, and to do most things online using a computer, because computers are almost always accurate.
This is how you find the Earth's gravitational constant.
Thank you for watching.